An airplane with an airspeed of 178 miles per hour is headed due north. Okay, I'm going to draw that much. So we've got a plane going due north and 178 miles per hour. If a west wind, so when they say west wind, they mean a wind blowing from the west. So we're going to draw a vector for the wind of 20 miles per hour. So this isn't drawn to scale, but we'll have them labeled, so we'll be good. It's blowing. Determine the direction traveled by the airplane and its ground speed, which is the actual speed with respect to the ground. So basically, we need to add these two vectors together, and then the resultant vector would be where they were headed. So let's take the plane, and then we'll add the wind vector up here at 20. And then our resultant vector, which is the way the plane will actually go, is right here. So now we need to figure out the actual ground speed and also the direction. So we need the direction and the magnitude of that vector, and then we've got it. Well, we've got two sides of the vector, so that's going to be pretty easy to find the magnitude. It's going to be 20 squared plus 178 squared square rooted, and what that'll give us is the ground speed. So let's go ahead and compute that, and it looks like that's going to be about 179.1 miles per hour for the speed relative to the ground that the airplane's moving. So it's what the engine's pushing it and the wind also. Okay, now let's figure out the angle. So this angle will be this angle right here. So maybe I'll make this triangle down this way as well, 178 down this way. And as we look at this, then we can see that tangent theta is going to be opposite 178 over adjacent 20. So we can grab the calculator then and figure out what theta is by doing inverse tangent. And it looks like we get 83.6 degrees.